In this lecture, we're going to discuss templates in more detail. Function templates enable you to conveniently specify a variety of related or overloaded functions called function template specializations. Class templates enable you to conveniently specify a variety of related classes called class template specializations. Programming with templates is known as generic programming. Function templates and class templates are like stencils out of which we trace shapes. Function templates and class templates are like the separate tracings that all have the same shape, but could be drawn in different colors, etc. So we're going to talk briefly, and we'll talk about it much more later in the course, about a concept of a data structure called a stack, which is a last in, first out type of structure, kind of like the little compression plates you place on top of things. Don't worry too much about how stacks work, because we're just going to use them as an example for building a template class. Another term for class templates are parameterized types, because they require one or more type parameters to specify how to customize a generic template. When a particular specialization is needed, use a concise, simple notation, and the compiler writes the specialization code for you. So, in order to create a class template, it looks like a class definition, but with a few differences. First, we begin with the class word template, and then the word type name and T, followed by a list of the template parameters. You can have more than one. Each template parameter that represents a type must be preceded by either of the interchangeable words type name or class. It's up to you. T acts as a placeholder for the stack's element type in this example. It could be any valid type. Type parameter names must be unique inside a template definition. The element type is mentioned generically throughout the stack class definition as T. That's tradition almost. The type parameter becomes associated with a specific type when you create an object using the class template. At that point, the compiler generates a copy of the class, but appropriately filled in. Another key difference is that we do not separate the class template's interface from its implementation. That doesn't work with templates, so you have to put them both in line. So here is an example of our stack definition. First, we're going to import DEC, which is a data structure we will talk about later on in the course. Then we're going to say that our class is a template class which takes a type name T. It's called stack. And everywhere we want to have a return value of a particular type that's generic or replaceable, we use T instead of like integer or long or etc. Okay? So a stack requires insertions and deletions only at its top. So here we have a top. It returns the data from the front of the stack. Like I said, we'll get into more discussion of the details later. We could store a vector or use a vector or a DEC, and we're going to pass all this because we don't need to talk about that. So, we could use inline to define something outside the class template definitions as follows. Come back to later, but I think it's simpler just to keep it all in one class. So, we built this template class, right? And here's how we use it. Here, first, I created a simple routine, or a main function, where we declare a stack, but say it's going to take type double. We're going to push some items onto the stack, call push. We're going to print them out. Then we're going to declare a call stack of type int, and we'll push some items on it, take them off. Then, since these two sections of code only differ by the types, I actually built a static function, a template function which takes a type and it will push out and do the same thing. But now this stack type is also sent in as a parameter. So here we can say we have a stack of T. So that further economizes our code. Now, there are other things you can have which are called non-type parameters. And they can have default arguments or constants. For example, in the C++ standard array definition, the template declaration begins with template class T and size T of n, where n is just a constant. Then when we instantiate it, we say array of type double and pass in the number 100 for the number of elements. That is very simple and clean, and we don't have to do anything particularly crazy. We can also have a default template argument where for a container class, for example, we have a class passed in called T and a class passed in called container, which defaults to a dec of type T. Default parameters must be the rightmost trailing parameters, and if you omit the rightmost, you have to omit them all. You can also overload function templates. When overloaded functions perform identical operations on different types of data, they can be expressed more compactly using function templates. You can then write function calls with different types, and if the compiler has enough information, you don't even have to tell it what type you're using. You can provide other function templates that specify the same function name but different function parameters. Basically, normal overloading. It works just like regular, but now you have to use the templates as long as it can distinguish between the different types. So there's a matching process involved. The compiler performs a matching process to determine what function to call when a function is invoked. It looks at both existing functions and function templates to locate a function or generate a function template specializing whose function name and argument are consistent with those type of the function calls. If there are no matches, the compiler issues an error message. If there are multiple matches, the compiler attempts to determine the best match. If there's more than one best match, the call is ambiguous and the compiler issues an error message. So, for example, if we go back to our example here, and I didn't specify the types for long stack and short stack, it's going to complain because it can't infer them. Okay. Similarly, for this function, long stack doesn't give us enough information to infer this sort of thing from. Well, that's an introduction to templates, which we need because we're going to start discussing the standard template library where templates are used and abused all over the